It is time now to start analyzing your evidence. You acquired your evidence, you made hash values of that evidence, you make a copy of it, and now it's time to analyze it. One part of the analysis that we're doing in forensics is to look for data that is hidden inside that drive. But before looking at data that is inside the drive, the first thing when you're analyzing is to do a search. If you have keywords that you are searching for, this is one of the first things that you're going to be doing. And looking at the data that you have that is not hidden, you will find in the normal places where data is kept, like my documents, like desktop, or any other place, a lot of data you will find. However, there are users who will choose to hide some of the information. We will talk here about information hiding. I want to say in the beginning that you can hide information not always because of criminal intent, but sometimes we use hiding information just as a way of keeping our privacy. Think, for example, that you worried about the security of your tax return file. It's on your computer, you use the software to create your tax returns, and it's stored in your computer. You don't want anybody to be able to look at the information because there's a wealth of information there about you, and you don't want your identity to be stolen. So you choose to hide a file like this. One of the ways that you will choose to hide it is by encrypting it, for example. So this one kind of use that is legitimate, that is not criminal. Also, any other information that you just don't want anybody else to be looking at it, you can hide it on your computer, and this is a legitimate use. However, here we're talking about crimes, and we're talking about criminals who are using hiding techniques in order to conceal the information inside their computers. Your role as a forensic investigator is to uncover all of this hidden data that we're talking about. Remember, we said that one of the first things that you would be doing is to do a search on the whole drive by keywords or by patterns, and search in a lot of times will reveal some of the data that is hidden. Some of the kinds of hidden data that I'll be describing here will be revealed by doing the search, but not all of them, and we'll explain one by one. I want to caution you again that you should first look at data that is available, that is just under your nose. Look at this data. A lot of cases can be proven from that available unhidden data. Add to that not all of computer users are savvy enough to be able to hide data using those methods I would be describing. Okay, so let's start exploring methods of hiding data in a computer. The very first method is the built-in hiding. We have a lot of applications that will have a feature that is designed to hide some data. Think, for example, about Microsoft Office, Microsoft Word, Excel, all of these applications. You have a way, for example, in a Word document to highlight any portion of the text, right-click on it, and then choose the font and check the box that says hidden there. I'll show you this in the next two slides. We have a Word document here, for example. It's full of random text, but I added a message here in the middle that says meet me at 12 noon at Main Street and Center Street. I highlighted this message, right click on it and go to font, and you see here I check the box that says hidden. The document here will appear for anybody who open it without that message. So if I'm agreeing with somebody that I'll be hiding messages, I'll just ask him to look for hidden messages. Another example, here I'm taking Excel worksheet, and I have column on this sheet that you see here, and let's say that I want to hide a whole column. I highlighted column B, which have all the grades of my students, that for some reason all of their names start with the letter J. I highlighted the column and right click on it and go to hide, and just click hide, and this column will be hidden. Anybody who's opening this worksheet will not be able to see the grades unless he knows that there is a hidden column, and he will be able to unhide it and then read it. Another way to hide a message inside the document is in all those documents that you can edit the color of the font in them. In this slide, for example, you can see that the second bullet here, you don't see anything beside it, or maybe you can see here barely because the color that I just chose for the font here is very similar to the background color. So if it's totally matching the background color, think of a white background or a totally black background, and you choose the font color to be the exact same, then this message will be basically hidden. How do you uncover some of the hidden messages, for example, in Microsoft Word? In Microsoft Word or any other Microsoft Office document, if you go to the file and then to the info and then check for issues and then do inspect document, you will see the results of the inspection. And some of the results that you can find here is any metadata that is about the document itself, like properties of the document, who's the author of the document. And here in the bottom, if you see hidden text, it's gonna say hidden text was found, and you can look for it and find it. I must say here though that this method will not reveal the font that we changed the color to make it similar to the background color, but if we are doing keyword search, the keyword search will be able to find and reveal any text that is hidden in any of those methods that we described so far. One more way of hiding messages or data inside files is with all these files that will give you the opportunity to add comments within the file itself or the source of the file itself. Not only comments, but also all the files that have metadata on the file, you can add and you can edit and you can insert any messages that you think about. In this case here we have an image and it's a JPEG file, and in the metadata section of it, as you see, I added a message inside it. So this will be hidden because whoever is opening this file, whoever is opening this image, will not be able to see the data that we have inserted in the comments or in the metadata fields that we have there. Unless this file is opened with something like a hex editor, like I did here, then it will be seen. Alternate data streams is a feature of the new technology file system, the NTFS file system, which is with us since the Windows NT. Alternate data streams will allow you to attach a file, or more than a file actually, to an existing file. I will show you how to do that in a simple short video in a minute, but for now you can see what I did here in this command prompt is I hide the text, hidden text, into a file called hidden1.txt, which is attached to an existing file called test1.txt. And this is the way it's done. This is the way how you open in the second line here, how you open the original file. In the third line, you can see how to open the alternate data stream. Again, when you attach a file to a file using this method, the size of the original file doesn't change at all. Microsoft actually made this happen in order to have the NTFS file system compatible with the HFS, the Mac file system. For this exercise, I will create a new directory here on my desktop. I will call it ADS, and we'll put everything inside it. I will go to my command prompt here, change the directory to the one that we are talking about. So I am in it right now. Just see if I have anything inside it or not. I don't have anything inside it, as you can see here. So now I will create a new file. I will call it, I will enter some text into it. This is a test of ADS
and I will save it into a file called test.txt. Alright, so if I show what is contained in this directory now, I have the test.txt here, and if I double click it here, also we're gonna see it, and that's this text that I have inside. This is the actual data that we have in the file. Now we will create alternate data streams or ADSs, and we'll do this in the following way. I will also enter some text into this file, and I'll say this is a hidden text for testing ADS, and I will direct that to go to the original file test.txt, then colon, and we'll call the new file hidden.txt. So now if I go back to what is contained in this directory, I still see only the original one. If I close this here, all I have in this directory is only this file, which is still the same what we entered inside it. This is a test of ADS, but I just created an ADS that is a file that is attached to this file, but it cannot be seen. However, the way to access it is by going back here, and let's say I want to read it. I know it's a notepad, or notepad can open that text file, so I'm gonna say notepad test.txt colon hidden.txt, and let's see what opens. This is the text that I put to hide inside that file. So this is the hidden text for testing ADS, and basically this is how ADS is created. A simple way to think of the alternate data stream is to think of an existing file of any kind. By the way, it can be, doesn't matter what the kind of the file, and that existing file is we are using it as a link to other multiple files that are hidden, that are not seen by the users. So in order for us to find alternate data streams, we have tools. We have a lot of tools actually available. Most famous is a tool called Streams from sysinternals, which is now Microsoft. Additional thing is, in Windows 7, Microsoft added a switch to a command, to the directory command, dir command, that will allow you to see if there is in the folder that you are in, if there is any data streams. So basically you go to the directory and you initiate the dir command with space and /r will show you all of these data streams. Of course, when you are analyzing hard drive, when you have an image and you're analyzing and you are starting a keyword search, if this keyword search exists in an alternate data stream, it will show in the search results. Now, creating partitions and then hiding the partition will be another way of hiding data inside your hard drive. Partitions are logical division of the hard disk. So basically we are dividing the hard disk to make it look as if it's two or more volumes on your computer. If you recall, the famous C drive is if you are creating one partition on the whole hard drive. So partitioning will make your hard drive look as if it's divided to different logical hard drives. So you can create the C drive, the D drive, the E drive, and all of them are on the same physical hard drive. You create partitions usually when you are installing your operating system. One of the questions that you're going to be asked is if you want to create partitions and how big the partitions are. Why do we create partitions usually? One cause would be that I want to install different operating system on the same hard drive, or I want to create the appearance of having separate hard drives. And we do that for file management. For example, I want to put all of my work related in one, all my work related documents in one drive, and all the operating system files on the other drive, or any other purpose that you can think about. So when you're formatting the hard drive, you could actually be creating different partitions, or you can, as most common would be, to make it one partition. Now once we created partitions, we can hide them. We use tools, disk editors, to hide the partitions, or we can use the Windows Disk Manager to hide the partitions. Partitions can be created also after you installed an operating system. If you have unallocated space on your disk enough, then you can use tools like Partition Magic and Gdisk and others to create more partitions on your computer. So now think of it like that. Let's say that a criminal is creating 2 or 3 partitions, and he's using one of those partitions to hide certain data that is criminal in nature, and he chooses to hide it. The hard drive is handed to you in order to investigate it, to analyze it, and what you're doing is, one of the first things that you're doing is to account for the amount of space that you have on that hard drive. An example would be, imagine that you're handled a hard drive of 100 gigs, and you're looking and analyzing that hard drive, and you see that there is only one partition of 90 gigs. So the first thing that you need to do is to account for those complete 100 gigs. If you're seeing only 90, then that should light a big warning light in your head to say, okay, what happened to the 10 other gigs that I have on this hard drive? Usually in those cases, those 10 would be a hidden partition. And inside the hidden partition, we can, of course, hide all the data that's inside it. Another method that we use in order to hide the content of a file is by changing and manipulating the file extension or the file signature, or both. Every kind of file have its own extension. For example, a picture, a photo can have the JPG extension, and it will have its own file signature, which is hexadecimal values, binary values translated to hexadecimal, that are unique to each kind of file. If we save a picture, for example, that we know that it's a JPEG, we save it as a different kind of file. Let's say, for example, we save it as a text document, document, then it will be impossible for the non-suspecting eye to see the content of that file. That picture will not open normally. For a normal user, he will not be able to see it on his computer. So this is another method that doesn't hide the data itself, but it will make it difficult or impossible for non-professionals to open that file. Changing a file extension can be simply done by just renaming the file and adding the extension that you want to add there. And changing the signature of the file can be done by opening the file with a hex editor and then changing the first bytes on that file to anything that you want that is not the actual known header of that file. The Windows Registry was introduced first with Windows 95, and it did replace the files WinINI, which controlled the desktop and all application on the computer system, and the file system INI, which controlled the computer's hardware, and the config sys, which loaded devices, drivers, and the autoexec.bat, which ran the startup programs and set the environment variables. Since then, we have the Windows Registry, and the Windows Registry is very important for our forensic investigation. Almost any investigation that we are dealing with, we will have wealth of information within the registry. The registry stores hardware and software configuration information, the network connections, the user preferences and setup information, and a lot of other information that is very important to our investigation.
The Windows registry is arranged logically into 5 hives that you see here. And examples of things that we can find in the registry is typed URLs, recent search terms, recent opened and saved folders, and a lot of other what we call MRUs, most recently used values that we can have, and it can relate to our investigation. We can also find devices, information about devices that were attached to the computer at some point, information about the installed programs, information about networks that we were connected to, and things like the default path to many location of potential forensic interest, such as the user cookies, the desktop, the favorites, the history, my pictures, recent items, start menu. All of these things are defined. The location for them is defined also in the registry. We will learn about the registry much more in the following class, which is ITN 277. But for this lecture, we are interested in hiding information inside the registry, and information can be hidden inside the registry if the user knows what he is doing and knows how to manipulate keys within the registry. This is the place also to warn you that any changes that you want to do in your own registry, please back up the key that you're dealing with, or the whole registry actually, just in order not to get into troubles when you change something that you should not have changed. What can the user hide inside keys of the registry? We can hide things like passwords, phrases, and we also can hide text information and binary files in the registry. Where could we hide this kind of information? Usually any values that you change on the registry will change the behavior of the computer, of the program that is using that key. Depends on the key that you're changing. But in the registry there are places that include keys that are not used by the system. A big example of that would be programs that were installed at some point in your computer, and those programs were uninstalled, but the keys for them in the registry is still there. So changing the information there will not affect the computer and the way that your computer works, but it will have this information. Also, there are various keys that are not needed and system does not use. That information can be stored in them. An example would be in the local machine key inside the system current control set. Under control there is a key called the time zone information, which have the time zone information, but there are two keys there that can be used for that. One called standard name and the other one called daylight name, as an example. Now we came to a subject that you probably already studied about in other classes, and this is a subject of data encryption. Data encryption actually does not hide the data. We know that there is a data there, but the data is scrambled and it is visible to us, but we cannot just read it. So the content of the data is hidden, but the existence of it is there. We see a scrambled text, a gibberish if you want, and we cannot read it. Bit shifting is one way of encryption, which basically just shift the bits for each byte that we have on the text or in the file. It's going to be shifting 1 or 2 or 3, depends what you want to do with it, to the right or to the left. And then when you want to read it, to decrypt it, you just shift it to the other way, the same number of shifts that you did to the original direction. Use Hex Workshop. This is another hex editing tool to experiment with bit shifting. Talking about encryption in general, encryption is one of the challenges to computer forensics. I want to say this is the reason why we don't just turn off the computer if we are able to access the computer before anybody turns it off. One of the reasons is to try to capture the memory in order to try to capture any decrypted files before we turn the computer off. In certain cases also we can get the keys that were used to encrypt certain kind of files from the memory. So capturing the memory would be
a very important step to do. Other ways to deal with the encrypted data from the forensic point of view is to try to crack the key that or the password that was used for encryption. That could be a very difficult task, but there are ways to create like a dictionary of known words that we can use from our knowledge about that case. In a lot of cases also, depending on the investigator of the case, we can just ask for the key, and you would be surprised to know how many cases can be resolved just by asking for the encryption key. Slack space, defined as the space between the end of a file and the end of the allocation unit. Allocation unit can be a cluster in a Windows machine or a block in a Linux Unix machine. Since sector is the smallest storage unit on the hard drive itself, and it is 512 bytes, and the smallest unit that a file system can write to is a cluster or a block. Now a cluster or a block can be one sector or more. Usually in machines that are running Windows nowadays, you're gonna see that every cluster is 8 sectors. This configuration can be actually changed, and you can know by running the fdisk command Linux machines. Now this area where the file ends and the unit ends can contain data. This data can come either from a previous file that was deleted from this unit, or from data that was intentionally put in there in order to hide the existence of the data itself. You can use tools as for example bmap. Bmap is a tool that you can use to write into a slack space of a file, and as such it is used to hide actually the information, because the file system cannot read the slack space data. Slack space, defined as the space between the end of a file and the end of the allocation.
Let us clear some information about slack space that we talked about before. I just want to show you on my computer here that any file that you have on your computer, if you right click on it, here's a text file here. If you right click on it and you go to properties, you will see, among other things, the location, of course, the size of the file. In this case, the size of the file is 803 bytes. And then we have another line that says the size on disk. The size on the disk is 4 kilobytes, 4096 bytes. That means that this file was very small, but it was stored in the smallest storing unit on my computer, and that smallest storing unit is a cluster that is made of 8 sectors, which will make 4096 bytes. So now this file is stored and it's occupying only 803, but on the computer itself it's occupying a whole cluster that is 4096 bytes. Now if we go to any other file, let me show you here. Here I have a PDF. Let's see what's going on with this PDF. I'll go to properties, and the size is 1.24 megabytes, and the size on the disk is 1.25 megabytes. And here in bytes you can see that it's occupying almost, let's see how many clusters this file is occupying right now. So it is 1310 kilobyte, which is 1,310 bytes. Divide that by 512 and you get 2500. Now divide by 8, because we have 8
sectors in a cluster, and we get 320 clusters that this file is occupying on my hard disk. Now let's say that I deleted this file. So all of these sectors, all of these clusters will be marked as ready to be written on. And since this is a big file here, the first cluster, if I save a file that is similar to this, to the smallest one here, to test2, then on that cluster, on this cluster here that was occupied by the file that I just deleted, and I saved a small file that is only 803, that means that the difference between the 803 and the 4096 bytes will still have the information that was before, and that difference between the 803 and the 496 in this case is the file slack. The file slack can contain information either from a previous file that was occupying that area, or it can be used to store data or to hide data that the file system will not be able to see. Since we're talking about this, let me show you also some other idea here. I'm gonna create a notepad, very small one. This is a test, and I will save it to my desktop as test also. I will save it to the desktop. This is a very small file. Here it is. Let's go to the properties of this file. We have something interesting here. The size of that file, you saw it was very small, it's only 15 bytes. But the size on disk is 0 bytes. What does that mean? Well, this is a case where the file is actually not stored on the file system on the hard disk, but it is stored in the MFT, meaning this file is so small that it could be contained within the master file table that we have within the NTFS file system. We call this kind of files a resident file, while all the other normal files that are on the disk are called non-resident files.
The last subject we will touch on in this context is the subject of steganography. Steganography is the art and science of hiding files in other files, meaning that we have a file that is a carrier. Usually it can be a picture, it can be a video or an audio file, and we hide another file inside it. The difference between steganography and encryption is that we don't see that there is a file hidden there. So imagine a situation where I hide a text message, a text file, inside a picture, and I email a picture to you. Anybody who is intercepting the email will see an email with a picture, and only you will know that there is a hidden file there that you can extract out of this picture and see the content of the hidden message. There are multiple ways to create steganography. The most used one is by changing the least significant bit inside every byte. As you see here in the picture, we have here 8 bytes, and the least significant bit is usually the one on the right side, because as you know, the value of each one on this side is 1, and the value of the one on the other side is 128. So the least significant is the 1, which means the bit on the right side. So if we change those, in order to create a message, as in this picture here, we created from 8 bytes, we created 1 byte that represents the letter A. Now the change to the carrier file, because we changed that least significant bit, will not be seen. It's going to be the difference will be minimal, and it will not be seen or felt in the carrier file itself. You will be doing a virtual lab about steganography, where you will use one of the tools that will be creating and hiding a file inside another file. Here are some of the many tools that you can use in order to create steganography. Hidden is one of them, and you have the link here. And WB Stego for Open is another tool. This is just an example of a lot of tools that you can find in order to create steganography. Steganalysis is the process of detecting the evidence of hidden data created by any steganographic technique or program, and when possible, not always that's possible, to extract that hidden data. Now I will remind you here that in order to be a good forensic investigator, one of the main things that you're going to be looking at is what you have, what programs are installed on the computer that you're investigating. If you suspect any steganography program that is installed there, or if you see any steganography program, then you should suspect that there are files that include in them hidden data using steganography. It's the same idea with cryptography. If you see, for example, that a TrueCrypt program or any other encryption program is installed on the computer, then you should suspect that you would find encrypted files on that computer. Why am I mentioning encryption again here in the context of steganography? Because some of the techniques that are used for hiding messages is to encrypt a message first and then to use steganography to hide it. So you should be aware of that too. Here are some of the tools that we can use for Steganalysis. The first tool, and you have the URL here, is StegSpy, and the other one is StegDetect. Of course, again, you should be aware what are the programs that are installed on the drive that you're investigating, because usually the same program that is creating the steganography, it is the same that is used to reveal that steganography. I want to mention here that all or most of the information that I talked about steganography is coming from a book that is available for you on the library, and it's called DataHiding. It's by Michael T. Rago and Hosmer, and the publisher is Sengris. It is an ebook that is available for you on the library, so you can go back to it free and read the chapter about steganography. This concludes the DataHiding lecture. We mentioned the most famous hiding techniques. There are more, of course, and more will come also, but this covers a wide range of techniques of hiding data. This is a place here also to remind you that this video, this class, is for educational purposes only. It is intended to teach you how to identify hidden data and how to reveal that hidden data.